Okay, so in this video I'm going to be doing the HSC 2009 paper for 3 unit. If you can, maximize your video now so that you can get the maximum most out of this video. But anyway, I'll be writing down the question as well. So the first question, so question 1a, it's asking me to factorize 8x cubed plus 27. Now as soon as you see this cubed part, you should be saying, okay, so it's obviously something to do with factorizing cubes, right? And what you really need to see is this 8x cubed and the 27 can be written up as 2x all cubed, right? And then plus 3 cubed. So what they're asking you to do is find the factorization of a cubed plus b cubed. So I hope you remember how to factorize this. It's quite easy. So what you do is, if it's a cubed plus b cubed, you write it as a plus b first of all, start off with, and then the second bracket, what goes inside there is quite similar to your quadratic stuff, right? So you have your a squared and then your plus b squared at the end. The only difference is, if it was a plus over here, it's going to be a minus, and then instead of 2ab, it's going to be a ab, right? So that's how you remember it. If it's a cubed plus b cubed, you start writing the same sign, right? And then just switch the sign over here without the 2. Alright, so getting back to this question, this is going to end up being, so it's 2x plus 3, right? And then inside the second bracket, it's going to be 4x squared minus 6x plus 9. Okay, so there you go. So that's part A done. Okay, let's go part B. Part B is asking you to find the domain of ln x minus 3. Now, any domain question, what you should be asking yourself is, what is the restriction? In this case, the restriction is that this part in here, the middle, the x minus 3 has to be positive, right? Because ln is not defined for negative numbers. You can go, what you need to end up saying is x minus 3 has to be greater than 0. Alright, so most domain questions will be something like this that you need to do. Now, when is x minus 3 greater than 0? That's simply when x is greater than 3. And also, if you're wondering, x minus 3 cannot be equal to 0 as well. Okay, so because ln of 0 is undefined. Okay, let's keep going. Part C. So part C is saying find the limit of x approaching 0 of sine 2x all on x. For this one, you need to remember that sine theta on theta, when it's approaching 0, is 1. Okay, so what I'm going to do is I'm going to manipulate this. I'm going to manipulate this limit and say, okay, I'm going to introduce a 2 over here. And because I introduced it, I obviously have to get rid of it, so I need to multiply by 2. See, these two cancel off, right? So it's the same question. I haven't done anything to it. Now what can happen is that this thing over here, that limit will go to 1. So my final answer is going to end up being 2. Alright, D. This is an inequality one, so I'm just going to get some more space. So for part D, what I need to do is find the solution for x plus 3 on 2x has to be greater than 1. Okay, okay, so I'm going to take the 2 onto the other side straight away. So I'm going to multiply both sides by 2 and then just write this as 2. Okay, now the x is actually the problem over here. Okay, so the x is the real problem. So what I need to do is multiply both sides by x squared. Okay, so the reason that I multiply by x squared is because I'm multiplying by a positive number, and that way the inequality sign stays exactly the same way it is. Alright, so I end up with x times, so this x will cancel with x squared, so I'll end up with x times x plus 3, and on the other hand I will end up with 2x squared. So remember, the little trick that you have to do is, whatever you see down here, okay, so whatever function of x that you see down here, you multiply by x squared. And if you're wondering why I didn't multiply by 4x squared because I had the 2 over here, That's because 2 is simply a constant. I can just move it around. Okay, so it's a positive constant, I should say. and I can just move it around. So I didn't really need to bother with that. Okay, so coming back to this, I have x squared plus 3x minus 2x squared. So taking it to this side has to be greater than 0. Okay, I really don't like dealing with minuses, so my mistake. I'm going to take everything back to this side again. So I will end up with x squared minus 3x has to be greater than 0, right? Now this is simply a parabola, right? So let me draw this out, and just so that you can see easily. Okay, so looking at this is simply going to be a smiley parabola, and when is that positive? It's positive when it's greater than 3. So you need to understand what I mean by positive. It's above the y-axis, right? So this is saying it has to be above the y-axis, and that's only when x is less than 0 and when x is greater than 3. Okay, so and again, you don't end up with saying equal to sign because there was no equal to over here. Okay, next part of the question, part D. Okay, so it's a differentiation question. So it says y is equal to x times cos squared x. Okay, so it's cos squared x, not cos x squared. So I need to differentiate this. Alright, so what do we use? We need to use product rule. So y dash is going to end up being, so x differentiated is simply going to be 1, so I end up with cos squared x, right? And the next time I leave the x alone and I differentiate this guy. So when I differentiate this guy, I will end up with times 2 cos x and then negative sine x. So I'm just going to write sine x over here for now, and then make this thing, instead of positive, I'm going to make that into a negative. Okay, so there you go. So I will end up with, and since you're doing 3 in it, you should be able to see, hey, maybe I can simplify this thing. The 2 cos x sine x, it's going to be sine 2x, right? So I will end up with cos squared x minus x times sine 2x, right? So that's my final answer. All right, and then the last part of the question, of that question 1, F, it's asking you to integrate this from 2 to 0 x squared e to the x cubed plus 1 dx, right? Using the substitution, u is equal to x cubed plus 1. Okay, so it will be great if you can do this integration without doing the substitution, okay? But if you're not so good with this, obviously you need to do this. So let me show you how I do substitution questions. So obviously I'm going to write this u equals x cubed plus 1, right? And then I have this little box that I do. So I'll show you what I mean by box. So du dx is going to be end up being 3x squared, right? So I'm going to write the dx on this side, and then I need to say when u is equal to 0, so the 0 from here, right? Sorry, not u's. When x is equal to 0, u is equal to 1, and when x is equal to 2, u is equal to, so that's going to be 8 plus 1, which is 9. Okay, so now I can change this integration. So when it's 0, it's 1. This is going to be, the upper limit is going to be 9. Now I have this x squared dx, right? I have this x squared dx, and I have x squared dx over here, but I have this extra 3 on here, right? So what I'm going to do is I'm going to move this 3 back, so it's going to be du on 3 instead. Okay, so forget about this 3 over here, it's du on 3. So x squared dx is going to be du on 3, and then this is simply going to be e to the u. Alright, so that's what we need to integrate. So integral of e to the u is simply going to be e to the u. So now, obviously, and I shouldn't forget the fact that I have 1/3 over here. So I have e to the u, and then 9 and 1. I need to substitute that in, and I will end up with a third, and in brackets e to the 9 minus e. Okay, so that is my final answer. So I mentioned before that if you should try and not use the substitution if you can, right? Because if you look at over here, I said u is equal to x cubed plus 1, right? You should always ask yourself the question, and I do mean always, if I differentiate one thing, for example this thing, do I get the other, right? So I don't exactly get 3x squared, right? But I do get the x squared. So the 3 doesn't really matter because it's a constant and I can move it around, right? So it will be great if you can jump to this step over here straight away. Okay, so so in the sense that when I integrate this, I will end up with 1/3 e to the x cubed plus 1. Okay, because what I personally do is, okay, I know it's going to be e to the x cubed plus 1, right? Because e to the anything integrated will end up with the same kind of form, right? So it will always end up being whatever's in here with it. And then you just do a little feedback thing. Okay, so first of all, I'll write this part, e to the x cubed plus 1. When I differentiate this, I get 3x squared. How do I get rid of the 3? I introduce a third in here. Now, if this is confusing, I've written up a tutorial on integration, like the summary on it, so look that up. But that's fine if you don't understand, just use substitution method. So let me know if you have any questions, and thanks for watching.